All right, for this video lesson, we're going to graph radical equations. Okay, so remember, equations will have an equal sign in them. If it's a function, there is no equal sign, essentially. Okay, so some of the key topics we're going to talk about today. We have domain and range of radicals of radical functions. Remember, functions are set equal to like y, right? Equations will be equal to 0. Okay, so we're going to talk about domain and range of radical functions, and we're also going to do some curve sketching with a lot of help from our calculator. Okay, so we will use the tools that we have available to us for on assessments and stuff to make our lives a little bit easier. Okay, all right, so looking at these top functions right here. So y is equal to 3x minus 5 and y is equal to negative x plus 2. Because the degree of the exponents here are just to the 1, we consider these to be linear functions. Okay, linear functions will look something like this. Okay, usually a straight line. Y is equal to mx plus b is the general form for slope for a linear equation. Okay, these next ones down here, so 3x squared minus 5x plus 1, negative 2 bracket x minus 1 squared plus 3, and 4 bracket x minus 2 bracket x minus 1. These are all quadratic equations. Okay, and these are all quadratics. All right. So, and sometimes we might need to expand the brackets to allow us to identify it as a quadratic, right? So this bottom one down here, we would just expand using FOIL. So we would get 4x squared plus x minus 2x minus 2. Combine our like terms. So we get 4x squared minus x minus 2. Now we can distribute that 4 in there, and we will get 4x squared minus 4x minus 8. Okay, and again, quadratic, the degree on our variable is 2. Okay. And yeah, sometimes we just need to expand to rewrite it. Okay, so going back to the first couple chapters that we did, this is in standard form. The second one here is in vertex form. And this last one down here is in factored form. Okay. Yeah, so my screen's just a little bit behind here, so we'll just give it a second to catch up. But yeah, so if the variable has a degree of 2, it is a quadratic function. Quadratic functions will look something like this. If it has a positive a value, it will open up. If it has a negative a value, it will open down. Okay. As I mentioned, my screen's a little bit behind, so I'm just pointing at standard form right now. So ax squared plus bx plus c will be standard form. Okay, negative 2x minus 1 squared plus 3 is in vertex form, where the negative 1 will be the x component of the vertex, and the +3 will be the y component. And when we are in factored form, we are able to easily identify the zeros or the roots of the equations. Those are the values that will set our equation equal to 0, which is, or y equal to 0, which is what we will find at the x-intercepts, right? Our y is 0 at our x-intercepts. Okay, we're just getting caught up with our notes here. So factored form is the bottom one, and then we will look at what a quadratic looks like. Okay, that should be nothing new for you guys. All right. So this will bring us into graphing radical equations. I'm just waiting for the iPad to load, catch up with the computer. Okay, so we were just seeing the quadratic being drawn, and here we are moving on to our next topic. Thank you for your patience. All right, let's get rid of that. Okay, so graphing radical equations. We can use our calculator to graph the following, which is really nice. Okay, so just go ahead and punch in y is equal to the square root of x. Okay, and then so when we are sketching, it's important that we know the domain and the range. Okay, so remember the domain is associated with the x values of a graph, and the range is associated with the y values of a graph. Okay, now when we are taking the square root of a number, x, any number, it needs to be positive. Okay, if you take the square root of a negative number, you will get an undefined answer, right? You cannot do that. Okay, so let's go ahead and graph y is equal to the square root of x, and it will look something like this. Okay, so for the domain, the x values, what is the domain of the function? Where does this graph exist? Okay, well, it is only from 0 going forward until infinity. Okay, it will increase without bound is what we say. Okay, so the domain, so x, where does this graph exist? Well, it exists when x is greater than or equal to 0. Okay, and this is where x is a set, or it belongs to the set of real numbers. Okay, XER. X belongs to a set of real numbers. So that is our domain. X is greater than or equal to 0. Okay, you can take the square root of 0 and it will just be 0, but you cannot take the square root of a negative number. Okay, that's why our graph only exists when x is greater than or equal to 0. Okay, for the range, so where do the y values exist on this graph? Well, y values will exist when y is greater than or equal to 0, and again, where y is a set of the reals, okay, set of the real numbers. Okay, so when we're looking for the range, we are going to be using our calculator for that. So that is going to make our lives a little bit easier. Okay, but just some notes here. So when we are finding the domain of a radical function, so to find the domain of a radical function, we make whatever is under the radical sign, so our radicand, we make whatever is under the radical sign, so the radicand, not negative. Or in other words, we make our radicand greater than or equal to 0. Okay, so that is important because if we try to take the square root of a negative number, it will give us an undefined answer. So to find the domain, we just need to find, or we need to make whatever radicand greater than or equal to 0, and we'll find the conditions on a case-by-case basis. Okay, so we need to make the radicand greater than or equal to 0 and solve for x. Okay, this will tell us the starting point of our graph. Okay. Okay, so yeah, so to find the domain, we are going to set our radicand greater than or equal to 0. Okay, and then we will solve for x. And this will tell us the starting point of our graph. Okay. Next question. We'll just let this get caught up. It's a little slow in this video. I apologize for that. Okay, so moving into finding the range of a radical function. So we are going to use our calculators for this. And we will find where the y values exist. Okay, so to find the range of a radical function, we use our calculators to find where y values exist. Okay, so on your calculator, so if we have y is equal to the square root of x entered in there, okay, make sure your window is set properly, but then you're going to press second graph, which is the table feature. Okay, and then you're going to scroll up and down until you find where it says y is in error. Okay, so look for the last value, the last known value of y. So for this example, when x is 0, y is 0. When x is -1, I have an error. And when x is greater than 1 or 0, so +1, y is 1. So my range for this is y is greater than or equal to 0, where y is a set or belongs to a set of real numbers. Okay, so second graph table and look for where it reads error in the y column. All right. So we have a function here, y is equal to x plus 2. So to find the domain, we're going to set the radicand greater than or equal to 0. So our radicand here is x plus 2 is greater than or equal to 0. So we will solve for which values of x will allow the radicand to be greater than or equal to 0. Okay, so we'll subtract 2 from both sides, and we're left with x is greater than or equal to -2. Okay, that is our domain. X is greater than or equal to -2. Okay, and same thing. So to find our range, you will go in second graph or the table feature and find where it reads error in the y column. Okay, so for the range of this function, y is greater than or equal to 0. Okay, for domain and range, we're going to assume that x is a set of the real numbers, and same with the range. Okay, so now that we know our range, so it only exists above our x-axis, right? Remember, y equals 0 at the x-axis. And this graph exists when x is greater than or equal to -2. So our point is here, our starting point, and it's going to look something like that. Okay. If you know your coordinate, you should write it down. So this is -2 and 0. All right. So this is graphing radical equations. We're just going to go through a few examples doing this kind of thing. So again, I will encourage you to pause and try these on your own. Okay, so y is equal to the root of 2x minus 1. So when we're finding the domain, without the use of our calculator, of course, we are going to set the radicand greater than or equal to 0. Okay, so in here we have 2x minus 1 is greater than or equal to 0. Now we will solve for x. So add 1 to both sides, and then divide by 2 to get x all by itself. Now we're left with x is greater than or equal to 1 over 2. Okay, that is our domain. And the range of this function, so again, we'll do second graph, your table button, right? And look for where it reads error for y. Okay, so our range, our y, the values where y exists is when y is greater than or equal to 1. Okay, so from those two pieces of information, we know the starting point of our graph. And because it's a positive square root, it's going to look similar to the other ones we've already sketched. It's going to go up and to the right. Okay, so our domain starts when x is greater than 1/2. So there's 1/2. And it also starts when y is greater than or equal to 1. So we're about right here. Okay, and our coordinate there is 1 over 2 and 1. All right. Motoring along. Okay, so our next one, y is equal to the square root of x squared. Okay, so we need to find when our radicand is greater than or equal to 0. Okay, so we'll just set x squared. We'll set x squared is greater than or equal to 0. We'll take the square roots of each side to isolate for x. Square root of 0 is just 0. So it'll be left when x is greater than or equal to 0. Okay. Now when x is greater or equal to 0, that would suggest that our graph only belongs in this portion, right? But when we have the square root of something squared, we need to analyze this a little bit. So think of if we have -6 squared. Okay, -6 times -6 gives us positive 36. And if we have just positive 6 squared, that will also give us 36. Okay, so any value for x, because it's squared, if it's a negative, like if x was -6, we would still get a positive value, right? So we know that x squared is always greater than or equal to 0. Okay, no matter what the x is, you are going to have a positive function. Okay, so let's go ahead and graph this. So the square root of x squared. Okay, so for any x value that is negative, it is going to be positive. So our graph is only going to belong in this range up here, right? If our x is -6, our y coordinate is going to be also 6, right? Square root of -6 squared would be the square root of 36, which is 6, right? And same thing if we have positive x values, it's still going to be positive. So if you have positive 6 over here, we're going to have 6 up here, right? So 6 and 6 and -6 and 6 up here. So our graph is going to look something like this. Okay, the y values will always be positive in this case. Okay, so the domain in this case, x is going to be a set of the real numbers. Okay, it exists for all values of x. Okay, the range of this function, what are my y values that exist? Well, we can only have positive y values. So for the range, our y must be greater than or equal to 0, right? We do not see any of this graph existing below the x-axis. All right. Okay, moving on. So the next one, 4 multiplied by the root 18x to the 3. Okay, so for the domain, we will set our radicand equal to 0. So 18x cubed is greater than or equal to 0. We will solve for our x. So 0 divided by 18 is 0. And then if we take the cube root of x cubed and the cubed root of 0 divided by 18, we get x is greater than or equal to 0. Okay, so that is our domain. And for our range, again, you're going to put this into your calculator, second graph or your table function, and look for where there are no values for y, where it reads error. Okay, and if you do that, you'll notice that the range for y is greater than or equal to 0. Okay. Yes, good. So now we can go ahead and sketch this. So if our very first point is when x is greater than or equal to 0, and when y is also greater than or equal to 0, so our first point is at the origin, and our graph goes up like this. All right. Okay, so next one, y is equal to -root4 minus x. Again, I'll encourage you to solve this on your own. So for the domain, we set our radicand equal to 0, so 4 or greater than or equal to 0. So 4 minus x is greater than or equal to 0. Add x to both sides. So 4 is greater than or equal to x. I don't really like it as when it's written in this way. I like to put my x first. So when x is less than or equal to 4, that is when the graph exists. Okay, so that is my domain when x is less than or equal to 4. Okay, so let's go ahead and put y is equal to negative 4 minus x into our calculators and do second graph. Let's look at that table to find the range. Where do the y values exist? Well, in this case, the y values exist when y is less than or equal to 0. Okay, note this negative in front. That just is going to like flip it the other way, right? Our other ones were when it's a positive x or positive coefficient in front of our radical, it opens up such as that. When it is a negative, it is going to open downwards, such as what we see in this example, okay? So our domain starts when x is less than or equal to 4. So there's our first point. And our range is all negative y values. So it's going to look something like this. Okay, my first point here is 4, 0. All right, we will continue. And again, I would encourage you guys to try these on your own. This one looks a little bit different. We have 2 bracket 1 minus 5x. So we should expand that 2 into that bracket first. Okay, so we will get y is equal to the square root of 2 minus 10x. Now we will set our radicand greater than or equal to 0. So 2 minus 10x is greater than or equal to 0. Let's add 10x to both sides. Just easier working with a positive coefficient on our x. Those will cancel. Now let's get x all by itself. So divide both sides by 10. So 2 divided by 10 reduced is 1 over 5 is greater than or equal to x. And again, let's rewrite this. So our x comes first. It's just easier for myself anyways to conceptualize that, okay? So x is less than or equal to 1 over 5. And that is our domain. Okay, so the range of this function. So again, put in root 2 bracket 1 minus 5x. And then we will do second graph. Okay, and where are the y values reading error? Well, when y is greater than or equal to 1.41, the graph exists. Any less than that value, there's no graph, okay? So let's go ahead and plot this point. So when x is less than 1 over 5 or less than 0.2, so this is about 1 over 5 right there, and 1.41 is about there. Okay, so let's plot our very first point, and our function looks something like this. All right, a couple more for today. All right, so y is equal to 3 times root of 2x minus 1. So again, when we're trying to find the domain, we just need to set the radicand equal to 0. Okay, so what my radicand is 2x. So when is that greater than or equal to 0? Divided by 2. X is greater than or equal to 0. That is my domain. And my range, so if you were to put this into your calculator and do second table, you'll find that your range only exists when y is greater than or equal to -1. Okay, so now let's go ahead and graph the function. So x is greater than 0, so it's going to the right. And y is greater than or equal to -1, so it's going up and to the right. Okay, so my first point is 0 and -1. And then it's going up and to the right. All right, and our last example for today's lesson. Okay, so finding the domain, let's set the radicand greater than or equal to 0. So my radicand is 2x greater than or equal to 0 divided by 2 by 2. X is greater than or equal to 0. Okay, and for the range, again, enter this into your calculator. You will find that your range only exists, or your y values only exists when y is greater than or equal to 3. Okay, so let's go ahead and plot this point. So x is greater than or equal to 0, so it's going to the right. And y is greater than or equal to 3, so it's going up and to the right. Okay, so our first point is right here, 0, 3, and it is going up and to the right. Okay, so that is today's lesson. You guys have an assignment to be completed and submitted for marks that has been included on the Google Classroom. So as always, if you need help with anything, don't hesitate to ask. Okay, I'm here to help you. So hope you have a great day and we'll see you soon.